Hey everyone, welcome back to the channel. Today we are going to break down two of the most important tools in Python, lists and tuples. You've probably used them before, but do you really know when to use one over the other? By the end of this video, you will. We are going to keep things simple, show you hands-on examples, and make sure you know exactly what's what. Let's get started. Part 1, Introduction to Lists and Tuples. Alright, before we dive into the differences, let's make sure we know what we're dealing with. Both lists and tuples are ways to store a bunch of items in Python. But here's the kicker, lists are like a to-do list that you can keep changing, add, remove, or update items anytime. Tuples, on the other hand, are like a photo. Once you snap it, it's done. You can't change anything in it. Let's see what this looks like in Python. Let's start by creating a simple list and a tuple in Python, which are two common ways to store collections of items. First, we'll create a list. Lists are created using square brackets and they can hold multiple items of any data type. In this example, we're creating a list with three integers 1, 2, and 3. When we print this list, you'll see the output as 1, 2, 3. This tells us that our list contains three elements just as we intended. Next, let's create a tuple. Tuples are created using parentheses and just like lists, they can hold multiple items. Here we're creating a tuple with the same three integers 1, 2, and 3. When we print this tuple, the output will be 1, 2, 3. This confirms that our tuple also contains three elements, but unlike the list, this tuple is immutable, meaning we can change its contents after it's created. So both lists and tuples can store collections of items, but they differ in how flexible they are. Lists are like notepads where you can add or remove notes anytime, while tuples are more like sealed envelopes. You can't change what's inside once they're sealed. Here's a list and a tuple. Simple, right? But trust me, the way they behave is totally different. Part 2, Simple differences. Now, let's talk about some of the simple but important differences between lists and tuples. I've put together a table to make it easy to see how they compare. Mutability. One of the main differences between lists and tuples is that lists are mutable, meaning you can change them after they are created. You can add, remove, or modify elements inside a list. For example, if you have my underscore list 1, 2, 3, you can later update it to my underscore list 1, 5, and it will become 1, 5, 3. On the other hand, tuples are immutable, which means that once you create a tuple, it cannot be changed. If you have my underscore tuple 1, 2, 3, you won't be able to modify or add elements, it's locked in as it is. Syntax, the way you define lists and tuples is different too. Lists are created using square brackets. For example, my underscore list 1, 2, 3 creates a list with three elements. Tuples, on the other hand, use parentheses. So my underscore tuple 1, 2, 3 creates a tuple with three elements. It's a small difference in how they're written, but it's important to know. Example syntax for lists, you use the square brackets. So creating a list looks like this, my underscore list 1, 2, 3. For tuples, you use parentheses. So creating a tuple looks like this, my underscore tuple 1, 2, 3. The syntax is straightforward and easy to remember, just brackets for lists and parentheses for tuples. Single element, there's a small but important detail when working with a single element in a list or a tuple. For a list, you just write single underscore element underscore list 1, and it's clear that it's a list with one element. For a tuple though, you need to include a comma like this, single underscore element underscore tuple 1. Without the comma, Python won't recognize it as a tuple. It's one of those little quirks that's easy to overlook but important to know. Performance and memory, because lists are mutable, they have a bit more overhead, which can make them slower than tuples, especially for large datasets or when you're just reading data. Tuples, being immutable, are faster since Python can optimize how they're stored and accessed. If you need something quick and efficient for reading data and you don't need to change it, tuples will often be faster. Memory usage, along with being faster, tuples also use less memory compared to lists. Since tuples don't need extra space to handle changes because they're immutable, Python can allocate exactly the right amount of memory. Lists, however, need extra memory reserve in case you want to add or remove elements, which means they take up more space. Built-in methods lists have a lot of built-in methods to help you modify them. For example, you can use methods like append to add elements, remove to delete elements, and sort to arrange elements in order. Tuples, since they are immutable, have fewer methods. You can still use count to find how many times a value appears or index to find the position of an element, but that's about it. Tuples are simpler because they don't change. Hashability, another key difference is that lists are not hashable, which means you can use them as keys in a dictionary or as elements in a set. This is because their content can change and Python needs keys to remain constant. Tuples, being immutable, are hashable. You can use them as keys in a dictionary or put them in a set, which is useful in many cases. When to use, in terms of when to use each, lists are best when you need a dynamic sequence of items, where you might want to add, remove, or change elements. Think of a shopping list that changes frequently. Tuples are best for fixed data that shouldn't change. For example, you might use a tuple to store coordinates like latitude and longitude and which won't change one set. Part 3, hands-on examples for simple differences. Let's see some of these simple differences in action with hands-on examples. In the first example, we modify the first element of a list, which works perfectly. However, trying to do the same with a tuple raises a type error because tuples are immutable next. We use the append method on a list to add a new item. This works fine with list, but trying the same on a tuple gives us an attribute error because tuples don't have an append method. Part 4, advanced and complex differences. Now that we've covered the basics, let's move on to some more advanced and complex differences between lists and tuples. Memory usage is use more memory because they are mutable. This means they need to reserve extra space for possible changes like adding or removing elements. The extra space allows lists to grow or shrink dynamically. On the other hand, tuples use less memory because they are immutable and have a fixed size. Once a tuple is created, its size can't change, so Python only allocates exactly the memory needed without any extra space for future modifications. Complex operations with list, you can perform all sorts of modifications. You can change elements, add new ones, extend the list with more elements, or slice it to get a portion of the list. For example, if you have my underscore list 1, 2, 3, you can change the second element to 4 using my underscore list 1, 4, and you can add more elements using my underscore list dot extend 5, 6 to get 1, 4, 3, 5, 6. With tuples, however, you can't modify them because they are immutable. You can only access elements and slice them. For instance, my underscore tuple 1, 2, 3 allows you to access my underscore tuple 1 to get 2, but you can't change it. You can also concatenate tuples like my underscore tuple 4, 5 to get 1, 2, 3, 4, 5. Thread safety, because lists can be modified, they are not inherently thread safe. If multiple threads try to modify a list at the same time, it can lead to unexpected issues. In multi-threaded environments, you would need to use locks or other synchronization mechanisms to avoid problems. Tuples, on the other hand, are inherently thread safe. Since they cannot be modified after creation, you don't have to worry about race conditions or data being changed by different threads. This makes tuples safer to use in concurrent programs. Use as dictionary keys, you cannot use lists as dictionary keys because lists are mutable, meaning their contents can change. Python requires dictionary keys to be immutable and hashable. For example, if you try to use a list as a key, like my underscore dict1, 2, 3 value, it will raise a type error. Tuples, however, can be used as dictionary keys as long as their elements are hashable, e.g., numbers or strings. For instance, my underscore dict1, 2, 3 value is valid because tuples are immutable. Complex methods lists have more complex methods available for modifying the list in place. For example, you can sort a list directly using my underscore list dot sort and the list will be sorted in place. Tuples don't have these in place modification methods because they are immutable. However, you can still sort the elements in a tuple by using sorted my underscore tuple, which returns a new list with the sorted elements, leaving the original tuple unchanged. Nested structures, both lists and tuples can contain other lists or tuples as elements, but how they can be modified differs. Lists allow you to contain other lists and modify them. For example, you could have my underscore list 1, 2, 3, 4, and then modify the inner list with my underscore list 0 dot append 5, resulting in 1, 2, 5, 3, 4. With tuples, you can also nest list or tuples, but the tuple itself cannot be modified. However, if a tuple contains a mutable object like a list, you can still modify that object. For example, my underscore tuple 1, 2, 3, 4 allows you to modify the inner list with my underscore tuple 0 dot append 5, resulting in 1, 2, 5, 3, 4. Tuple unpacking. Both lists and tuples support unpacking, but it's more common with tuples. With lists, you can unpack elements into separate variables like a b, c1, 2, 3. However, tuples are often used for unpacking because they are frequently used to return multiple values from a function. For example, a b my underscore function would return a tuple that gets unpacked into a and b. Heterogeneous data storage. Both lists and tuples can store different types of data, but they're often used differently. Lists are usually used to store similar items like a list of numbers or strings. However, you can mix data types as well. For example, my underscore list apple 42 3.14 contains a string, an integer, and a float. Tuples, on the other hand, are often used for storing different types of data that are related in some way. For instance, you might store a person's name, age, and job title in a tuple like person John, 30 engineer, where each element has a specific meaning. Part 5, hands-on examples for complex differences. Let's explore some of these advanced differences with hands-on examples in the Jupyter notebook. In the first part of the code, we are working with a list. The list my underscore list is created with three elements 1, 2, 3. Since lists in Python are mutable, we can modify their contents after they are created. The line my underscore list 1, 4 modifies the second element at index 1 of the list from 2, 4. After the modification, the list becomes 1, 4, 3, and when printed, it outputs modified list 1, 4, 3. This demonstrates that lists allow changes to their elements freely due to their mutable nature. In the second part, we switch to a tuple. We create a tuple, my underscore tuple, with the values 1, 2, 3. Tuples, however, are immutable, which means that once they are created, you cannot change, add, or remove any elements. When we attempt to modify the second element of the tuple using my underscore tuple 14, Python raises a type error because tuples do not support item assignment. The code uses a try dot 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 except block to catch this error and print it, preventing the program from crashing. The error message that gets printed is error with tuple object does not support item assignment. This part of the code demonstrates that tuples are immutable, meaning their structure and values cannot be changed after creation. In next example, we are working with nested structures in both lists and tuples. First, with the nested list, we create a list containing two inner lists 1, 2, 3, 4. Lists in Python are mutable, which means both the outer list and the inner list can be modified. We modify the first inner list by appending the value 5 using nested underscore list 0.print5. This operation adds 5 to the end of the first inner list, transforming the overall structure to 1, 2, 5, 3, 4. The result is printed, showing the modified nested list. Next, we work with the nested tuple 1, 2, 3, 4. Tuples in Python are immutable, meaning that the tuple itself cannot be changed. You cannot add, remove, or modify the elements of the tuple. However, in this case, the tuple contains mutable objects lists as its elements. Even though we cannot change the tuple structure, we can still modify the contents of the inner lists. By using nested underscore tuple 0 dot append 5, we append 5 to the first inner list, changing it to 1, 2, 5, and the overall structure of the tuple becomes 1, 2, 5, 3, 4. The tuple itself remains intact, but the mutable objects within it can still be altered. In this example, we are demonstrating tuple unpacking in Python, a convenient way to assign multiple values returned by a function to separate variables. The function return underscore multiple returns a tuple containing three elements 1, a, and true. When this function is called, the returned tuple is automatically unpacked into the variables x, y, and using the line x, y, z, y is return underscore multiple. This process assigns the value 1 to x, the value to e, and the value true to z. After unpacking, we print the values of x, y, and using print unpack tuple x, y, z, which outputs unpack tuple 1 are true. This example highlights how Python's tuple unpacking feature allows for easy assignment of multiple values to individual variables in a single concise operation. It's particularly useful when working with functions that return multiple values. And that's a wrap. We've covered both the simple and complex differences between lists and tuples in Python. I hope this deep dive has given you a clearer understanding of when to use each one in your projects. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more Python tips and tutorials. If you have any questions or topics you'd like me to cover, drop a comment below. Thanks for watching and I'll see you in the next video.